Alright folks, Chapter 3 is all about functions. So we are going to start out by reviewing all of the parent functions that you saw in Algebra 2. So what I'm going to have you do for each problem here, you'll see a space for equation and for the sketch. Right above it somewhere, I want you to label each one we talk about here. The first step is identity, also known as just a linear function or line. And what we're going to do for the sketch is always do the most basic version of this based on the equation's most basic version. So for a line, usually y equals mx plus b, the parent function is y equals x. All the other numbers have gone away. And we're going to sketch that. We know a line starts at 0, 0, and then slope of 1 here is what we're talking about, going up and to the right from there. I want you to label that 0, 0 because it's going to be important for what we do next class. For today, we just need to know the domain and the range of this parent function. Looking from left to right, all x values are fair game, so that's negative infinity to positive infinity. Same thing goes for the range, all the way through the graph. Next up, we're going to talk about the absolute value parent function, and that's y equals the absolute value of x. Write the name and the equation for me. So the absolute value kind of takes on the shape of a line, as in when you're looking at the first quadrant, it goes up and right from there, slope of 1. But what's different than the last one is instead of going down on the left-hand side, because this is taking the absolute value, it's changing all of those negatives to positive, so it goes up from there instead. We're still at 0, 0. Domain is still all real numbers from left to right, but we're not using all of the graph anymore. This one starts at 0 and goes past to infinity. Next up is the cubic function. You're less familiar than this. The parent function is y equals x cubed. Again, write cubic at the top for me. This one still starts at 0, 0 because when you take a 0 and cube it, it's still 0. You'll notice that the right-hand side of the graph goes up and it almost makes a parabola shape. It's a little bit steeper because we're cubing it instead of squaring it. On the left-hand side, what's different than a parabola is this side goes down because when we take negative x values and cube them, they stay negative. Negative times negative times negative. So we're starting low, doing a little snake shape, going up from there. Still hitting 0, 0. Put that on your graph. Domain is all real numbers from left to right, but the range is 2 from up, or bottom to top. Next up is exponential. We've talked about this year. So we're going to write y equals b to the x. I know generally we say ab to the x, but we're going to talk about transformations. So what's really important here is to know when we're talking about the parent function, there's going to be some number there. So when you were in Algebra 2, you said the graph of something, and then you talked about transformations that had happened to it, purple note card stuff. We're always going to include the base in our parent function. This is not the b value from that purple note card. It's the b value as in the base. And we're going to sketch growth for us. So start low, go high. And then two things that we want to put on here. One, instead of having 0, 0, we actually have an asymptote at y equals 0 that must be labeled. And then another important point, instead of 0, 0, we have 0, 1, or more specifically 0a. We talked about that with exponentials this year. And based on this, our domain is all real numbers, left to right. We hit everything. But from the bottom, we don't actually touch that 0. We want to put a parenthesis. Then we go up from there. The one in Algebra 2 that you're probably least familiar with is this one. It's called the greatest integer function, or the step function. It's called a step function because it looks like a staircase going on here. We're going to talk about this graph particularly in detail in a couple of lessons. So what we're going to do right now is just remember that it makes a staircase, and on the left of our step it's closed, and on the right of our step it's opened. So here we're starting at 0, 0, and then to the right of it put an open dot. Go ahead and connect them. And then we're going to copy that step just a little bit higher. Our open dots and closed will line up with each other. And you just need to do a couple on each side of that first one. So this way, below that 0, 0, you're going to put open, and then to its left, closed. And then we'll just do one more. And this does go on forever just like the rest, so I just throw arrows on the end to indicate that. The parent function is y equals, kind of looks like an absolute value, but there are these little feet at the bottom of it. This means to round down the number. So we have this staircase happening because we're taking all of these x values that fall between 0 and 1, and we're rounding them down to 0. That goes with the y value. All of the numbers from 1 to almost 2, like 1.9, they're rounding down to 1. So all of these are at a height of 1, and so on. And when we think about rounding, the domain is all real numbers because you can round any number in the world down. The range, however, is different because we're rounding to the integer below it. So the range, we actually have to use set notation. Start out with your set bracket, and then we'll say y such that y is an element of the integers, which is double bar z. Again, we will talk about this one in more detail down the road, so don't worry if that's a little bit strange for today. The next one is a hyperbola 1 over x. We talked about this in Chapter 2 as well. So go ahead and jot your parent function down. I will call this an inverse more commonly than a hyperbola, because the hyperbola is the shape, the inverse is the parent function itself. What is important for an inverse are the asymptotes that happen. We've got vertical asymptote happening because when we look at 1 over x, if you try to plug in x equals 0 here, you're taking 1 divided by 0, and that's not allowed. That's the whole idea of restrictions in the domain, or any time we have a domain that's not all real numbers. It's because there's a problem happening in the parent function when you plug in that value. So we're starting off with a vertical asymptote and calling it x equals 0. Then, because we can't plug in 0 to this, and the way our fraction looks, we're also not going to get 0 to come out. So there's also a horizontal asymptote at y equals 0. Then our branches just curve on the positive side. When you put a positive in, you get a positive out. Same thing over here. When you put a negative in, you get a negative out. So start at your asymptote, curve, and head towards your other one. And do the same thing in quadrant 3. And with that in mind, our domain and range just leave out those asymptote values. So negative infinity to 0, not included, union with 0 to infinity. Range just copies that same pattern. Then we've got the inverse square. Just like its name, it just means you take that denominator and you square it. So parent function is y equals 1 over x squared. Go ahead and jot down the name here. We still, for an inverse square, have an asymptote at x equals 0. Because we still can't have that denominator be 0. Similarly, when we can't plug in 0, we can't get 0 out. So we've got y equals 0. What's different is where your branches on this show up. We still put in a positive, get out a positive, but the difference is here, because we're squaring on the denominator, when you put in a negative value and square it, it actually changes to positive. So we're only using the top half of this graph. Use the asymptotes to guide you when you're drawing those branches. Our domain is the same as it was last time. You can plug in any number as long as it's not 0. So we're stopping there. But because of that squaring, we're not starting at the negative side like we did on the last one. We're starting at that 0 value. We do have an asymptote, so neither side here is included. Parabola, this one we're very familiar with, y equals x squared. I will call this quadratic rather than a parabola, because parabola describes the shape, quadratic describes the equation. This starts at 0, 0 and makes a U shape or parabola shape going up. This 0, 0 is important, just like it has been the whole time. And our domain, you can square every single number in the world, so all real numbers. But when you square them, only positives or 0 come out, so 0 to infinity. Square root function is next. We've got y equals the square root of x. This one is a little bit interesting as we talk about the graph. We still start at 0, 0. But you'll notice on the picture I have here, we only have this part of the graph going to the right. We don't have anything on the other side. The reason for that, again, when we're talking about the domain or the x values, it's just saying what's okay to plug in. 0 is okay to plug in because we can take the square root of 0. Over here on the right, positive numbers are okay to plug in. Some of them are nice, some of them are not so nice, but they always work. Where the problem shows up is on the left. If you try to go plug in -2, we can't take the square root of a negative number in the real number system. And for that reason, we're starting at 0, going up and over. Our domain starts at 0 included, and then goes to infinity. Same thing with the range. Lowest value we see is 0, goes to infinity from there. Go ahead and write that 0, 0 again. All of these points or asymptotes that we've been putting on these graphs are going to be important when we talk about sketching graphs based on transformation.